Jai Jinendra, Namaste, welcome to my channel. Today we are going to solve the 31st question of the problem solving series, and we are going to start the new topic, binary search. So find the first and last position of element in a sorted array. So we are given an array in the form of vector which is sorted, and we are also given a target element. We need to find the first and the last position of the target element in the sorted array. For example, here the array is 5, 7, 7, 8, 8, 10 and our target element is 8. So we need to find its first occurrence and the last occurrence and add it into our vector or anything, and we need to return those first and last occurrence. So here in this example we can see that the 8 appears in the second, third, fourth, fifth. In the third, if we take the array as a zero based indexing, so first occurrence is 3 and the second last occurrence is 4. So our answer would be 3, 4 in our vector. In the second example we can see we need to find 2 and the first occurrence of 2 is in the second part of the element and the last occurrence is in the fifth part. So our answer would be 2 and 5. So between 2 and 5, all the elements from 2 and 5, all the elements of the array is the target element, which is 2 here. So we need to return this. The difficulty level for this question is medium, and this is the first question of the binary search. So what is binary search? We know about linear search, right? Whenever we want to find any element in the array or any other structure, we search it linearly, and if we find the element what we are searching, we return it. So what is the time complexity for a linear search? It's order of n. So suppose if you would want to return the first and last occurrence using normal linear search, what we would have done? You would have searched for target element. Whenever we find a target element, we store the first index and then we keep on continuing it. And if we don't find a target element, we know the previous element was its target element. We have the first element and the last element, we return it. What would be the time complexity? In that case, it would be, in linear search, it would be order of n, right? We can easily solve it. But the question is sorted. We have a sorted array and we can apply binary search only when our array is sorted. Sorted means the elements are in the form of increasing order. It's given it's in increasing order. So now how can we use binary search to find the first and the last element? So with binary search, the time complexity is order of log n. And I would believe that you know binary search. In my previous array topic, we have discussed one of the questions which involved using binary search. So what do? Whenever we have an array, since it is a sorted array, that means the elements are always increasing, we find the middle part of the array, right? For example, here the first element of the array is 5 and the last element is 10. So the index is 0 and 5. So 0 plus 5 by 2 is 2 and 2.5, which is 2. That means the second element would be its middle element, right? Middlemost element. So we see whether this second element is equal to the target element or not. If it is equal to the target element, we will return it. But if it is less than the target element, in this example, what does this mean? This means that the element 8, since it is greater than the middle element, will obviously be in the right side of the elements. So we remove all the leftmost part, because if this element is lesser than 8, then all the elements which are to the left part of it, since those left part of it would be lesser than the this element, so it will obviously be less than the target elements. So we will eliminate the leftmost part, right? And our search will start from 8 to 10. Okay, so again we will search from here to here and we will find the middle element. If the middle element is equal to the target element, we will return it. If it is, for example, here 3 plus 5 by 2 is 4, so our middle element is 4. So the middle element A4 is equal to the target element, we got the target element. So in this way we will be using our binary search. But how will we have solved the problem when we need to find its first occurrence? For example, here we found that the element 8, we have found it in the 4th place, but this was not its first position. This is actually its last position, right? So how will we make sure that the element is actually the first occurrence and the next search the element is its last occurrence? How we will ensure that? So here in this case, when we find this is the fourth element, so it could be the lastmost, it could be the firstmost, or it could be in the middle of any element, right? We don't know because the elements are repeated, right? So in that case, what we will do, we will try to reduce it. We will still be searching so normal binary search, what we do, we have a low, we have mid, we have high, right? So here we will not stop our search and we will return it. We will make the search again, we will reduce the search to the leftmost part. We will eliminate the rightmost part because the rightmost part will obviously be greater than this. But the leftmost part will either be less than this or equal to this. So we have eliminated again the half part. So every time we are eliminating half of the search space. That's why, since we are eliminating half of the search space every time, so our search time complexity is log n. That is the basic of binary search. Now coming back to how do we solve the first and the last occurrence. Here when we have found the fourth element, then we have again our search space, since it starts from here. So we will eliminate this part 8 and 10 and we will search from 8 and 8. So the third plus fourth by 2, 3 plus 4 by 2 is 3, and this 3 index is equal to the target element. So now, since low, and so now our answer could be this one, right? So this could be our first occurrence, but we are not sure. So if we again continue our binary search, when does the binary search get terminated? In the normal case, the binary search gets terminated when we find the answer, or if we don't have the answer in our binary search, when low becomes greater than high, then our binary search gets terminated. So we will have our answer every time, but when we see that the low becomes greater or than or equal to high, then we terminate it. And since we will be storing this index every time, so we will find the index as 3 and we will store it. So this way we will find the first occurrence. How will we find the last occurrence? For finding the last occurrence, we will reverse it. Here in this case we have eliminated from 8 to 10, the right part, because we wanted the smallest part of the search. But when we want to find the highest part of the search, we will not eliminate the right part, rather we will eliminate the left part and we find the exact element, right? So in this way we will be able to solve it. I will write the pseudocode and then you will understand how we will solve this problem using binary search, right? So we need to find, obviously we'll have only two elements in the vector, right? So say if we have a vector as vector int result, and we will find first as a first occurrence, first element, and we will give this array. And since we are applying this first element function is the function where we are applying the binary search, so what we will do, we will just give the size of the array, right? So if the size is int n is equal to array dot size, right? So array n and the target, right? Assuming this will give our first occurrence, and so we have got our first occurrence, and this last, if this first, say if we don't find any element, right? So if there is no search, then we will return -1. So if first equal to -1, then we don't need to search anything, right? If this is the condition, if there is no first element, that means if we don't have the search, then we need to insert probably -1. So we will just add result dot add first result dot actually pushback last, and we will return result, right? But if we have got the first element, then we need to find last element as well, say last occurrence, right? and we will return the last. We will have a function which find the last occurrence using the binary search, eliminating the leftmost part, and when we find the element, and then we will just add result dot pushback first and then last, and then we will in the end we will return result, right? In this way we will be able to solve this problem using binary search in order of log n. So let me code the binary search function first element. So here we have first element function. We have the array, say nums and n and target, right? Now, so we will apply the binary first search logic here. Low would be 0, high would be n minus 1, right? While low less than equal to high, we will continue our binary search, right? And we will have, say, int first equal to -1, since we are finding the first occurrence, and we will return first. If we don't find the value, then the first value will be obviously -1. But if we find the value, so we will have int mid equal to low plus high divided by 2, right? So what do we do if num mid is equal to target, right? Then what does this mean? That we have got the element which is equal to the target. So our first would be mid position, right? That for sure we are going to do this, but we are not going to terminate it now. What we will do, since we have got the element, the target element, but we need to find the leftmost target element size, right? So we'll still remove the rightmost part. So we will make high equal to mid minus 1. High equal to mid minus 1, right? Else, if nums mid is less than target, what does this mean? That the middlemost element is less than the target. What does this mean? This means that our search space should be towards the right size, right? So our low would be mid plus 1, right? We need to increase our mid value, then only it could reach the target part. If it is the middle element is greater than the target element, that means we have crossed the target value, and we need to reduce the search space to get the target value, right? So the mid has crossed. If mid has crossed the target value, so in that case we will make high value is equal to mid minus 1, so that we search in the left space. In this way we will find the first occurrence of the element in the array, and then we need to find the last occurrence. So for finding the last occurrence, here in this part of the code for last occurrence, we need to make low is equal to mid plus 1 instead of high equal to mid minus 1. So we find the rightmost part of the target element. So once we have both the first and the last occurrence, we will add that into the vector and we will return it. So I think the question is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough section of this problem in the LeetCode platform. So you can see find first and last position of element in sorted array. We are given the vector of nums and the target element. You can see in this example 5, 7, 7, 8, 8, 10. Target is 8. The first and the last occurrences are third and the fourth index range. Okay, when the elements are not there, for example, you see the second example, the target was 6 and we don't have 6 in the nums array, so we return -1, -1. So you can see this code here. Also, I'd like to tell you that this question was actually asked to me in the Amazon interview that I gave 2 months before. I was able to solve this question, but couldn't crack the complete Amazon interview. Anyways, so here you can see this search range. We have taken the vector of result and we are finding the first occurrence. We have written this function for first occurrence. We have passed the nums array, the size of the array and the target element. And here we have applied the binary search logic. You can see here when the element is equal to k, the mid element, then we make the first is equal to mid and high is equal to mid minus 1, so that we are looking for a smaller index. Once we find the smallest index, then we get our first occurrence. Similarly, for the last occurrence, we always look for the rightmost index. So here in this case, the array of mid when equal to k, we make the low as equal to mid plus 1. So once this condition gets terminated, then we have the last as mid, which is the last occurrence, and in this case it is the first occurrence. So in this way we get the first and the last occurrence and we add it to the result vector and we return the vector. So let's run it. So we see all the test cases have passed, so we will submit this. So yeah, the solution has been accepted. So hope you like the solution, and see you in this next video where I'll be explaining the 32nd question of the problem solving series. Thank you.